Good morning, students. In today's digital electronic class, we are going to explain you the concepts of finite state machine by using Mealy and Mori machine, right? So basically, before proceeding with today's class, I'll just take the overview of the previous class, what we have discussed in the previous class. In the previous class, we have just talked about the concepts which we have left in the last classes, like we have discussed PLDs, CPLD and FPGA. That architectures we have seen, that is a part of unit 3 that we covered, and unit 4 we have talked about the sequential circuits, latches, flip-flops we have taken. We left with one topic called excitation table of flip-flops and how do we convert the flip-flops. That part we left in unit 4, right? Next, come back to the unit 5. In today's class, we are going to deal with unit 5, FSM. Right? What is FSM stands for? It is nothing but finite state machine. So basically, what's the meaning of the finite state machine? It is a sequential circuit basically. What is the meaning of the sequential circuit? Sequential circuits are the circuit which consists of a combination of the inputs and it has the memory elements. Memory element in the form of flip-flops it has, and then the sequential circuit is further classified into two parts. So sequential circuit is a circuit which consists of combination circuit with the memory element. It is again classified into two parts. One is the asynchronous sequential circuit. Another is what? Synchronous. So in asynchronous sequential circuit, we do have the registers, counters, where by using the flip-flops we are going to deal with that. In synchronous part, we are going to deal with the finite state machine. That is nothing but two types of machine. In that we do have to learn it. One is the Mori and another is Mealy. So we are going to learn these two types of machine in finite state machines. So by the name itself, it is a finite state. Finite state in the sense, the stages, what are the stages we do have in sequential circuit? It has three kind of stages. One is a previous state, present state and the next state. So what is the previous state means? The state before giving the output to it, what are the things we are giving the inputs? Those are nothing but the previous state. Likewise, present state. Present state means what? If you want to write as a present state as Q of t, what is the previous state we can write over either? Q of t minus 1, right? That's the previous one. What is the next state of that particular term? We can write Q of t plus 1. So based upon the states, we are going to design the FSM, that is finite state machine. So in that we are going to deal with models of sequential circuit which has input, output and internal states. So which can be customized by using the two models. One is a Mealy, another is a Mori. So both are going to design by using the same concepts. So what is the things we are going to see here? So we are saying that this Mealy and Mori, in that we will be having the same, what I said just now, three things. One is the input, output and internal status. So what are the internal states? So what I am saying, whatever the machines of finite state we are going to design, it consists of input, output and internal state. So what are the internal states we do just now learn? These are the internal states we had. So when you want to design FSM with either Mori or Mealy, both consist of input, output and internal state. So both are going to design in the same way, but one only depends on input, another depends upon input as well as output. The output of that function. So suppose output is depends upon present state and previous state, and in another machine output depends upon only present state. So when we had these two kind of concepts, when the outputs are depends upon only present inputs, then it is considered to be the model of both inputs and output state is depends upon both the values of present state and inputs, then it is a Mealy model. So output depends upon present state or previous state or internal state. So then this type of model is called what, students? So this is called it as Mealy model. So whatever the models we are going to say about that, that is a Mealy. So we are saying for this model is what? It's a Mealy model. Where output depends upon only present state, then it is called as Mori model. So how this model is going to be designed? Present state or internal state, when the output depends upon the present state as well as the input. That input, whatever the inputs we are saying, present state and the input, previous state, or you can say this as what? Input. When it depends upon these two particular states, then it is called as Mealy model. So in Mealy model, what actually the output would be? Output depends upon the present state as well as input. Whereas in Mori, the output is a function of only the present state. So output is only the function of present state only. Here input is not going to be considered. Such type of model is considered to be the Mori model. Okay. So students, we are going to design these two particular Mealy machine and Mori machine by using the design procedure for it, by considering these two concepts into the consideration. One concept is that the output depends upon present state and the input. Present state means what? This Q of t. Input is what? Whatever the values A, B, C we are giving. So it depends upon both the values. Then it is called it as Mealy model. What about the Mori then? Output of the present state. Output of the function, or output is a function of present state only. If only present state is there, then it is called Mori model. Let us see how the circuitry is there and what are the blocks it consists of based upon this Mealy and Mori model. So students, so next we do have Mealy machine and Mori machine, right? So both are the types of finite state machine. So in that, what are the things we are going to learn? We are going to see, just now we have seen Mealy type is a functions which depends upon present input as well as the present state as well as the input. So basically, what is the meaning of the Mealy machine? So how the Mealy machine is going to be designed? So in that, as you can see here, it consists of three blocks. One is the next state combination logic. Next we do have a state register. Next we do have output combination logic. So in that, the basic thing what we are going to see here is how we are giving the input and the states. What are the different state of Mealy type of machine we do have, how it is going to take that particular value for it. So as we know that for the Mealy machine, output is a function of present state as well as the input. So you can see there, when you are passing the input to the next state combination logic. Meaning is that whatever the combination logic is there, first thing they need to take the particular stage for that value, then the same input we are passing to the output combination logics. That means whatever the input we are giving, it giving the input to simultaneously two ways. One is for next stage combination logic and then output combination logic. So in that way we give the input, and as soon as the combination logic state get the input, it pass to the state registers. So basically what are the registers? It's a combination of the flip-flops. So when you want to get the flip-flop into the consideration, so in that the state register is going to take that value, and based upon what type of registers you are designing, means what type of flip-flops you just want to take it, whether it is JK, SR or toggle or D flip-flop, based upon it you are going to use that particular registers, and then it is again passing to the output combination logic circuitry. So in that, the first input is going to be passed to both the values, and again, so from there we are having the inputs. What are the inputs we are giving? We are giving the inputs. From there again, as soon as it reaches to the state register, we do have one more connection over there. As you can see here, this is passing again fed back, just like a feedback. Again it is fed back to the combination logic. And keep on checking for the values until and unless it reach out to the output combination circuitry. So the block of Mealy machine is this way. What about the Mori machine? This is the block of Mori machine of finite state machine, or FSM, right? So as you can see here, we do have a feedback. That feedback we don't have in Mori. So what is a Mori? It depends upon only present state, don't depends upon the inputs. That's the reason once input is given, it is passed once only. Meaning is that whatever the inputs we are giving at one end only, that for the next state combination logic only it is going to give the input, and again it is passed to the state register, whereas it is giving the clock pulses because we want to get whether it is edge triggered or level sensitive, whatever the may be. The thing is we just want to give that particular to the state registers, and we are going to the output combination circuitry, and the output is what? Mori type. What is the meaning of Mori type? It depends upon present state only, right? This is the way the Mealy machine and the Mori machine is going to be designed by using FSM. And one more point for Mori or Mealy is that in Mealy machine, whatever the values we are getting, the output of Mealy machine is the value that is present immediately before the active of edge clock pulse. So what I just read just now, I read that the output of Mealy machine is the value that is present. Whatever the values that is present, this registers, it is having the clock pulse, right? So immediately before whatever the values we do have, it is going to be taken into consideration in Mealy machine, right? So since we are giving the clock pulse, so that output of the Mealy machine is the value that is present immediately before the active edge of the clock pulse, because it is both are the synchronous type of sequential circuitry, right? So whereas in Mori machine the output is having the two functions, right? The whatever the output is there, it depends upon the present state as well as the input. So that's the reason input is passing to the directly output. Again it is getting back, that is a fed back to the what? Next state combination circuitry. So here we can say that the output in the Mori machine are synchronized with the clock because they are depends on flip-flop output that are synchronized with the clock. So because of that reason, we say that Mori machine is a sequential circuitry which depends upon the value of flip-flops, and it is a function of present state which can be designed by using the state table. So what is the state table? How do we design state tables and all? That also we had, I'm going to explain you after these concepts. How do we design the state diagram? So state diagram, to design the state diagram we have to use a certain steps. So that steps, and how do we get that particular circuitry to develop that particular state diagrams for both Mealy machine, Mori machine, and even for the counters and registers. Those things I will going to tell you when we get that particular thing. So here what we have learned, students, so we have learned that Mealy machine and Mori machine both is a function for present state and input. In Mori it has only the function of present state, whereas in Mealy it depends upon both present state as well as the input. So just draw these two things. If they ask to design, you can explain about FSM for both of them, and you can write it down about this Mealy and Mori machines. Okay, so both can be designed by using a state diagram and state table. So basically to get the state diagram, state table, first thing you should have circuit diagram. So after getting circuit diagrams, you can pass that particular thing to the equations. Means by using K-map, by using any kind of functions, you have to develop the equation. Then we need to prepare the state table. After getting the state table, we have to write the state diagram. Right? So something, if you want to have circuit diagram, like if I had, just I'll take the example of one NAND gate. This is my circuitry. What is the equation of NAND gate? If it A and B is the input, this equation would be A into B, right? I need to prepare a table for that. Means I need to prepare A, B, I'll take, and I'll write the output. This is called as what? Table. So 0, 0, 0, 1 for AND, right? Next thing, I have to draw its state diagram. Means what? First input is what? 0, 0. Then it is passing to the 0, 1. Next it is passing to the 1, 0. Next it is passing to the 1, 1. Again it is coming back to this end. So this is the steps to design the state diagram. To design the state diagram, that is the next concept we do have. So that's the way we can write it down, the state table to the state diagram. So once again I'm repeating, students, it's somewhat not clear over there. So what I said, we have to design the state diagram. This is our concept state diagram. To design it, this is the 4 steps we need to follow. One would be the drawing the circuit diagram. Means what? Whatever the circuitry they'll give in the question, you have to draw that particular circuitry. After getting that circuitry, you have to write its equations. So instead of this, if you had somewhat different, complicated like this, NOT gate and passing to the OR gate and all that, so we have to write the output. This is AB, this is B bar. So we have to add AB plus B bar. This is called what? This is called equations, right? We are writing the state equations. Yeah, so we got the state equations. Then after that, we have to write a table. We should draw the table AB, then take a B complement, then add both the values 1 0 1 0, then add B and B bar. AB is there, AB we had this. Then we need to add both. So 1 0 1 1, like this, something. That is called table we are developing. After developing a table, we have to draw the diagram based upon the states, right? So this is the way we can write the circuitry. Whatever the circuitry we do have, we can design that state equations as well as the state table by considering the state diagram. So that was the next concept we do have. Just I gave a brief introduction to design the state diagram for the state tables. So next students, so we are going to learn about this Mealy and Mori machines. We have learned already. Just I want to revise once again because this is an important question. They'll keep on asking about it. Explain the Mealy and Mori machine. So what we did students, so we said that Mealy and Mori both are the example of FSM. What is FSM? FSM is nothing but finite state machines. What is the state means what? State means what? It can be present state and the previous state and can be the future state. That is nothing but next state. Present, past and next. We consider to be in that way. So that is what? It's a finite, means whatever the values we are giving, both are finite. So both Mealy and Mori machine are going to design by considering the 3 steps. One step is combination circuitry. It is called next. Next, why we are saying? Because we just want to write the combination circuitry over there and we want to write the next step for that. So that's the reason we say here is next state combination logic. So then it is passing the state registers, which consists of flip-flops, and we are giving the clock pulse to it. That is going to give the edge triggered for it. If they want to get the triggering of the clock pulses, it is going to get from the clock. And again it is passing to the output combination logic circuitry, and output is what? Mealy type. So in Mealy type, depends upon present state as well as the inputs. That's what input is passing directly to this next state as well as input is passing to the output of the combination logic circuitry. Whereas in Mori machines, directly we are giving input, and again this is a feedback which is common in both. So here, whatever the clock pulse we are giving the state registers that going to be designed from the state registers, which is a combination of flip-flops, and we are going to get the output. So this is the way your Mealy machine and Mori machine is going to be designed. And in Mori machine, you have to note down that output is a sequential circuit which is synchronized. Both Mealy and Mori, what I said, both are synchronized sequential circuitry. So both can be synchronized with clock pulses because they depends upon the flip-flop output that are synchronized with the clock. Whereas in Mori machine, so Mori machine, what I said, the output of the Mori machine is the value that is present immediately before the active edge of the clock. So these 2 points you have to write it down for Mealy machine and Mori machine for designing the FSM. So in the next class we are going to go for this state diagram by taking the circuitry examples. Like we'll design for the flip-flops, that is SR, JK and all that. We'll take the state diagram for that, and even we'll design the counters and registers by using the JK types of flip-flops. Okay, so that's it about today's class.